What's the conjugate of this? It's an exact copy of itself, changing the sign that links them. A times the square root of B minus C times the square root of D. And it doesn't at this point matter what A and B and C or D are. So we're going to do our best to kind of like prove that this works for everything. So when we have this times this, we're going to write it all out. We're going to say that's going to be A times the square root of B times A times the square root of B, multiplying these. The inside terms are going to be all these multiplied together. And I'm going to write that as C times the square root of D times A root B, just this times this term. But then I have a minus sign when I multiply these, so that minus sign goes there, and it's C root D times this one. So I'm going to write it as C root D times A root B. And so what I have in the last position is these multiplied together. So I have a negative times a positive, which gives me negative C times root D, C times root D. So C root D times C root D, minus sign there. Now, before I go any farther, I see right away that this entire center term just cancels and goes to 0 because even though it's giant, C root D times A root B, C root D times A root B. There's a subtraction, so they all go away. And then finally, what I'm going to have here is A times A giving me A squared. Square root of B times square root of 3b is square root of B squared because I can multiply the b's under the radical. I have a minus sign from here. C times C is C squared. And then square root of D times the square root of D, which means square root of D squared there. And then I can see I'm going to have A squared times this cancellation here will be B minus C squared, this cancellation D. So I have A squared B minus C squared D. Learn anything at mathandscience.com.